Hi there. Hi, everyone. Good morning for those who are on the West Coast. Good afternoon, and maybe even good evening for folks joining us from around the world. Really glad to have you all here today. This talk came about in an interesting way. We got a lot of asks about MLOps since that's what we work on at Verda, and I'd run a similar talk for Strata, which got a really great response. And so we thought we would open this up for a wider audience who might not have had access to Strata at that point. So thrilled to be being able to share this with everyone. All right. So let's get started. I believe that everyone who wanted to check out Slack is on there, but here's the link, bit.ly ModelDB MLOps, and then hop into the webinar channel. This Slack channel is our generic sort of ModelDB community, Verdoc community channel. So like you could ask questions about getting started with ModelDB, also about the webinar, anything where we can be helpful. All right, so without further ado, a bit about who's going to be speaking today. So I'm Manasi. You guys might know me from previous webinars that you might have attended. I'm an engineer by training. I now run Verda. I got my PhD from CSAIL, the computer science lab at MIT, and my focus was data science and machine learning infrastructure. So one of the key systems that I built, and a topic very close to my heart as a result, is model management and versioning. We'd run a previous talk on that. We'll reference ModelDB briefly during the walkthrough later today. I'm also joined by my fabulous colleague, Michael, who's going to be leading the hands-on part of this session. He comes from a cognitive science background, worked on audio analysis. He knows incredible things about Python and is probably the most fun presenter in our group. So I think you'll really enjoy when he walks you through how to build an MLOps pipeline. And a bit about Verda, since we're still relatively small. We build open source and open core software for the entire model lifecycle, including versioning, deployment, and ops. And we're super excited about that particular intersection where we're building for data scientists, but we're building something that scales. That was something that we saw at Twitter, at Google, NVIDIA, and we have tried to incorporate that into everything that we do. So with that very brief intro, let's get started. We got a lot of ground to cover. This particular webinar will have two parts. The first one is just an intro to MLOps. I'm going to be walking through why should you care about MLOps, what is MLOps, and then I will hand over to Michael, who's going to walk you through actual code to build an entire pipeline. All of the code is already on GitHub, so if you want to try it out after the webinar, it's all going to be there. It's fairly involved, so I would say that if you follow what Michael's doing in the second part and then try to replicate it yourself, it should be pretty straightforward. And then we'll leave a lot of time for questions as well. Awesome. Okay, so let's get started. A lot of people in the audience today mentioned that they are data scientists or ML engineers. And generally what we're seeing across the board is, compared to 5 years ago, models have become easy to build. Whether that's our pre-trained models, you know, the BERTs, the Hugging Face models, OpenCV models, or FastAI models. If you want to solve a data science problem, building a model is not going to be the challenge. It might be the use case, maybe the data is very large and unwieldy, you need to clean it, but getting to a model has become easier. What is still a challenge is the delivery and operations of ML products, which is why we're running this session. What do I mean by that? Once you build a model, there are various steps that need to happen before the model can be integrated into a product. For instance, one of these tweets from IBM say that it took one of their teams 3 weeks to develop a model, but it took them over 11 months to actually deploy it. And even at the end of that, the model wasn't fully deployed. We see this across the spectrum, small companies, large companies. One of our close partners used to take them 20+ weeks to bring a new version of a model into production. And it turned out that with better infrastructure and processes, they were able to reduce this to less than a week. and they've been able to very rapidly do their model deployments as a result. Finally, once you have models that are in production, just like any other software application, you want to make sure that they are working as expected. You're looking at latency, throughput, all of the systems monitoring, as well as data monitoring things that are relevant for ML. So that's the landscape today. And the question is, why is ML delivery and ops so hard? Like, we've solved this question for software. It's called DevOps. So what's unique about ML? The first one, there are three challenges that we've identified. The first one is model development is quite different from software development, empirical and ad hoc. As data scientists, we just like to experiment a lot, fudge around with our features. We clean our data sets a whole bunch of times. We try different kinds of models. We also do grid searches. And by the time we find a final model, it's very hard to go back. And while this might seem like it's a quirk of data science, once you put your models into production, this lack of a lineage for where a model came from really hampers the ability to quickly deploy and manage models. And so we found that if you want to have robust ML ops, you actually need to start from the development phase and be very rigorous about how models are generated and tracked. So that's challenge one. The second challenge is data science, ML, and software are different worlds. I have sort of straddled both worlds for a little while and have a lot of respect for both sides. As a data scientist, I love the flexibility, just write some code, get it working, ship around Jupyter notebooks, not worry too much about latency throughput. However, when I ship my code to the software engineers, what they care about is scale. They care about generalization, and they're going to be on the line if something goes off with a model. So we're finding that bringing these models into products, the key thing that we need to be careful about is how do we make this transition very smooth and very seamless. So as you're thinking about ML ops, that's the second challenge that you'll have to address. And these days we have pretty good tools to do that. The last challenge here is that existing tools, even DevOps tools, are not really ML aware. So for instance, if you think about monitoring, think about your app dynamics or your Datadog, etc. They're not really meant for monitoring ML models. So things like data drift are really hard to trace there. It's hard to apply complex Python functions. Resource utilization can be different depending on CPU, GPU, TPU. Optimization, so going a level deeper, not just data science, but how do I run this particular workload efficiently? That turns out to be different for ML. And scheduling also is a really interesting research problem for ML. So that's the set of challenges that come up when you're trying to operationalize models. Operationalize, productionize, you're going to hear a lot of these words used interchangeably. So what we found after helping a number of companies bring their models into production is the thing that's missing, or the thing that can really help accelerate the delivery of ML models, is ML ops. And this is really the constructs of DevOps, or the abstractions of DevOps applied to ML. If you think to why DevOps started, about a decade back, the goal was to deliver software products faster and more reliably. This DevOps sort of infinite loop should be familiar to a lot of people in the audience. We, at this point, have a lot of great tools for every piece of this loop, going from planning to building to testing to packaging, release, configuration, monitoring, and then going back to planning. So it's taken a village or a lot of tools in order to enable us to build and deliver software products rapidly. If we look at ML ops, right, we have the same goal. We want to deliver ML products faster. We want to do that reliably. However, we're still very early with ML. And so on the left side of this loop, on the ML side, we do have pretty good tooling. We have PyTorch, TensorFlow, Jupyter. They're awesome for getting started. We're also getting better with testing. I think we can do a lot better, but cross-validation, just basic stuff, Lime, Shapley help us make sure our models are working as expected. However, when you go to the ops side, there aren't a lot of good ML-specific tools that are available. and that us as data scientists or ML engineers can adopt very easily. So in this talk, we're going to focus exclusively, more or less, on the operation side. So we're going to assume that everyone is pretty good at building models. What we're going to help you do is go from I have a model to I have a model service that I can deploy into a robust production system and have it run at scale. So that's what you can expect for the next sort of 30, 40 minutes. And the next half of the talk is going to be very hands-on, where Michael is actually going to walk you through code. And what we're going to do is we're going to go through building an MLOps pipeline with entirely open source components. So that's Docker, Jenkins, and Prometheus. For those who are not familiar with it, Docker, containerization platform. Jenkins is a way to automate your builds. And then Prometheus is a great monitoring library that has been used very frequently. So that's our plan. We also have all the code available on GitHub, as I mentioned. So before we get started there, let me just hand over to Michael and run a short poll to make sure that we're on the same page. Bear with us, these polls help us make sure that we're not losing anyone as we proceed. Okay, Michael, over to you now.
All right.
Wonderful. Looks like everyone's on the same page. So Michael, please take it away.
Let's see. Perfect. Are you able to see my screen? Looks like we'll be good to go. So, thanks, Manasi. So now that we have some conceptual context, let's go through what a robust MLOps pipeline actually looks like, how it's built, and how it's used with open source tools, including, as mentioned before, Docker, Jenkins, and Prometheus. And if you're not too familiar with these, don't even worry about it. I'll show you what they look like shortly. Let's imagine that we're working at a hot new AI-driven startup, TweetTrader, and our product centers around social media analytics. We build and train models that take in tweets, figure out the sentiments of those tweets, whether they're negative or positive, and then profit. So TweetTrader, our engineers and data scientists, will embark on building out our MLOps pipeline. First, we'll train a number of models until we converge on one that shows promise. Then we'll use Docker, a popular open source platform, to build a container to host that model so that it can be deployed as a service. Next, to enable consistent and reproducible builds, we'll use Jenkins, another open source tool, to help automate a build and release pipeline. And finally, when the model is deployed, we'll use an open source software called Prometheus that will record and display metrics from our model. For more fine-grained information, we'll collect logs from the model as well. Now, let's take a look at how these steps are done in practice. So I have here a Jupyter Notebook. It's a common tool, as you might know, for data scientists to build and iterate on their machine learning models in Python. And iterate I have, because during my time here at TweetTrader, my coworkers and I have tinkered with dozens and dozens of models trying to obtain that one that has the accuracy that our product deserves. And finally, I believe I have found it right here. So my models are built with Spacey, which is a popular Python library for natural language processing. And my data set comes from a bucket I have on S3. It consists, of course, of various tweets along with their associated sentiments, 0 for negative, 1 for positive. So I load in a general purpose English model from Spacey and fine tune it on my data set so that it learns to classify tweets by sentiment. Then, when the model completes its education, I'll store it, the actual model itself, back to S3 so that I can use it later. Since this is a spacey model, I actually need to upload two artifacts, the model itself, along with a metadata JSON. Once that's good to go, we're ready to move on to the packaging step. I have three little scripts to accomplish this. First, fetchModel.py is going to pull these two model artifacts back from S3 and download them to local disk. Then I have a predictor.py that will use Flask, which is another Python library, to run a server that will host my model. And I've also added some instrumentation that exposes logs as well as metrics. And finally, I have a Docker file that specifies how to build this container, including the model and that Flask script that I'll be able to use to host my model in any environment. Onward. I've defined a pipeline here that runs those three packaging steps that enables me to release my model. And when I run it, note that I need to specify the S3 locations of my model and the metadata JSON from earlier in order to build and release the correct model. Now, executing this pipeline actually takes a while, so I did that in advance, and we can go ahead and see this model in action. Ooh, I have a couple more scripts that will allow us to do that. First, run.sh will bring up that Docker container that I've built using Jenkins. Then I can use predict.sh to make some queries to the model. A couple of English tweets I'd like to get the sentiments of. So we'll bring up that model. We'll make our predictions. Ooh. We'll make our predictions. There we go. So there we have it, the two predictions for our two inputs. And we can get a better look at what happened by checking the logs. So there it is. These were our two input phrases from earlier. I think that's wonderful. And bedtime, why did you have to leave? Which expectedly are positive and negative. We can also view the metrics being exposed by our model through Prometheus. So this graph shows that influx of requests that the model received just now. So that process was fairly straightforward and stable. I built my model in Python, packaged it into a Docker container, released it through Jenkins, and monitored its metrics through Prometheus, and saw its logs upon prediction. But what happens in the wild? What happens when I put my precious, cherished model out into the real world? Imagine this. I, the eager machine learning researcher at TweetTrader, wake up one morning and I take a look at my logs. I look over my metrics. Something's off. The live data looks weird. The predictions make no sense. Our product suddenly finds itself exposed to a new market, and we're getting tweets in German. I wouldn't have seen this coming at all, and I start to panic a little. I take a few tweets in German, perhaps, run them through my model, and yeah, it thinks good morning and good night are negative, and I disagree, along with I am angry, come back as positive. So I rush back to the drawing board, right? Something needs to be changed. The model needs to be retrained. So, okay, I dig through my data sets, right? Did anyone work with German tweets? Here's one, but it looks a little small and it's 2 months old. Is there a newer one in a different bucket? I'm not sure. I look through our models. We have dozens of them stored. Maybe one of them can handle other languages, but there are so many. I can't tell who worked on which ones, and I can't verify anything with my colleagues because I don't know who actually made progress on these. And I have so many notebooks on my computer, and my team emailed me a few yesterday. I don't know where to look. And overnight, our company's product has gone from good times to bad times, and progress comes to a standstill, and we need to regather our bearings and debug our model. And even if the situation weren't so dire, even if it was just as simple as a coworker has a better model that I'd like to incorporate into mine, I'd have the same struggle of tracking down exactly what data, what code, what Python packages, what model configuration are of interest. So it sounds like there's a gap in our process here. Something was missing from our pipeline that constricted our workflow as soon as something went wrong. I can't verify the latest versions of data sets. I don't know who created what models, and I'm not sure what the relationship between all my Jupyter notebooks are. And the truth is that we kind of skipped a small detail. We haven't actually solved the ML part of MLOps. You see, the piece that we're missing, tracking versions of components, figuring out who's responsible for what change, might actually sound familiar to you. It's the same piece occupied by version control systems like Git and Mercurial in DevOps. When we build software in the DevOps loop, every change made is tracked. We know who did it, what they did with commit messages, and of course, what they actually did. If we start seeing a particular error, we can simply revisit our project's history to start identifying what is misbehaving, pull in potential solutions, and still keep track of these fixes that we're applying. Yet, when it comes to machine learning, when a model outputs unexpected results, this is a familiar nightmare to many data scientists and researchers, I would have to dig through my file system to remember which notebook I was using, all the random text files I was using to store information during training, realize what files I may have deleted or even just lost with no way to recover them. I need a versioning system for machine learning models, something that can uniquely identify a model and all its components for reproducibility, merging, diffing, something that integrates pleasantly into my workflows. Where could I find such a system, you might inquire? Well, some of you may be aware that we at Verda have been working on one, ModelDB. This open source system started at MIT, and we're rebuilding it from the ground up to help tie together robust MLOps pipelines with model versioning. So let's fix the pipeline. For the rest of this talk, I'll be bringing in ModelDB as my versioning system. All I have to do is, during the training step, introduce ModelDB to version my model components, and that's it. Everything else downstream is nearly the same, yet more robust. How is this possible? I'll show you. Let's train a model. So this time, it's multilingual. And I'm using our client library to establish a connection to ModelDB, which I have running on my machine, and setting up a project and experiment to organize my machine learning work. And aside from the inclusion of all important German training data, my actual workflow remains the same. The only additional piece, the formerly missing piece, is to version my model. Here, I'm using utilities from the client to automatically pick up information about my Jupyter Notebook file and Git environment, the hyperparameter I'm using to configure my model, metadata about my English and German dataset, and my Python environment, package versions and all. And I simply log these as a commit to ModelDB, log my model, and associate everything together, and that's it. The run of my experiment, along with the versions of my model's ingredients, are all linked to each other. And I can find all the things I just recorded in the ModelDB web app. Every artifact I need to serve the model, information about my Python environment, my code notebook, the Git environment as well, and of course, the data set I have on S3, including those German tweets. So if I had the system earlier, right, I could have seen exactly what model and data I was using, and I would have been able to quickly update whatever I needed to. And not just for this run. With ModelDB, I can get this same granularity of information for all runs I've done in the past and in the future. So now, when I go to Jenkins to build and release my model, I don't have to dig up the locations of all my individual artifacts on S3. All I need is my one model ID, which you can think of as being analogous to a commit ID in, say, Git. And as with before, I run this pipeline ahead of time. And when I run this new model, versioned with ModelDB, I'm confident that I have the right pieces and I know exactly where I can find them later on. And I can make my predictions. The English tweets are still accurate as expected. And now the German tweets are as well. We did it, right? Good morning and good night are positive and very good indeed. And all we had to do was introduce a versioning component. And just like that, the build was simpler, the release was safer, everything downstream is the same as before, yet the whole pipeline is much more robust. So we can handle these situations with ease, and Tweet Trader lives to see another funding round. And with that, I'll hand it back to you, Manasi.
All right. Thank you, Michael. I'm assuming folks can see my screen now. Okay, perfect. Okay, that was a whirlwind tour through what it takes to build an MLOps pipeline. We know we went through a lot of different steps, and so I want to take the next 5 minutes or so to just recap what we did and open it up for questions since we didn't have a break in between. All right, so what Michael did was he trained a model. It was a spacey model. He tested out a whole bunch of models before he could obtain the final one. In round 2 of this building of the MLOps pipeline, he used ModelDB as a versioning system. You might have an in-house versioning system, homegrown versioning system, whatever works for you. But essentially what we got out of it was that we had a unique identifier for our models, which could help us go back to what artifacts were used, what code was used, what data was used in hyperparams. So if you wanted to ever go back and either update a model or you wanted to merge 2 branches of development on a particular model, you want to do PR reviews, etc., you could do it just by having this basic versioning system that's very much like Git. So that was step 1. Our step 2 was just a Docker container. What that did was it fetched the artifacts from S3. In the ModelDB case, it got a particular model ID, and then ModelDB magic got the right artifacts down. Michael had built a Flask web server, which is surprisingly scalable for a lot of cases that we come across. And then finally, he packaged it all into a Docker file. And the Docker file, all it's doing is running, it's copying over the files. The Docker container is then going to serve this particular model. So that's our step 2. Pretty straightforward. The third one is Jenkins. And I can't emphasize how important this one is when you have to deploy models reliably. Suppose you had a particular Docker file on your local machine, and then for whatever reason you didn't commit it, you're not going to be able to reproduce that exact model the next time around. So having your model building and deployment step in a consistent manner is really facilitated by Jenkins. And most of the software applications out there do use Jenkins, Circle CI. GitLab for CI/CD. So this can fit right in there and is super easy to set up. The next thing Michael did that was kind of hidden under the hood is we had multiple Docker containers running. We used Docker Compose in order to bring all of these containers up and then start serving predictions. Also look at the monitoring of these predictions on Prometheus and look at logs. So that's a crucial step as well. If you're on Kubernetes, then you're going to have either Helm charts or you're going to create services, deployments, etc., in order to run your model on Kubernetes. The last step that we saw was Prometheus. So as you are making predictions on your model, the basic things that you want to keep track of are how many requests are you getting? How long did a particular request take? What was the throughput of your model serving, etc. So that's the simplest way to do that is actually with Prometheus. You can expose a set of metrics that you care about, and Prometheus will not only store the metrics, but also show them to you in a visual dashboard. Prometheus often ends up being used with Grafana to do visualizations. The last piece that we did do was logs. Logs are super important, even if you have good monitoring. These let you dump out arbitrary information, just our regular old print statements that will help you debug what's going on in the model. So that's what we did. We covered a lot of ground, but if you wanted to recreate this whole pipeline from scratch, you could do it in under an hour. It just takes a little bit of setup on the Jenkins side and Prometheus side. After that's done, you're good to go. So that was a whirlwind view of MLOps, why model versioning fits in and how it fits in. We went fairly quickly through all of the material. That leaves us with more time than I expected for questions. So before I go to questions, let me just throw up the 3 key takeaways that we hope you will take from this particular webinar. The first one is MLOps. MLOps is just DevOps, but for ML. It's going to help you ship ML products faster. And as we transition from focusing on building models to actually deploying models, it's going to become more crucial. Model versioning to MLOps is really what Git is to DevOps. It's as essential and as crucial to get right. We ended up using ModelDB in this particular webinar. Feel free to replace that by another system that you might have. Otherwise, check out ModelDB too. And then we presented a MLOps pipeline that can run end to end. So that's all we have for today. We would love to take questions from the audience, whether it's about how to do particular pieces, how ModelDB works, how Prometheus works, whatever you like. Feel free to put them either on the GoToWebinar Q&A section or on the Slack channel. Slack is a bit easier for us so we can have a longer conversation, but we want to make sure we address your questions adequately. And the last thing I'll mention here is we are running a MLOps Salon, which is in June. This webinar was one way to do MLOps, the one that we've seen work well. But the Salon is going to be a more panel-focused discussion where you can hear from 4 sort of top companies and top ML practitioners on how they've set up their pipelines. So with that, let me open it up to questions. Please feel free to throw them at either location, as I mentioned, and we'll just work through them. And I'm going to check the questions on my phone so I can answer them quickly.
Awesome. So we had a couple questions come through, Manasi. One was, what do you think of reinforcement models?
Reinforcement learning and how this fits in. I'm guessing that that's the question that was asked. So reinforcement learning is super complex, right? Because you're constantly updating your models in real time, etc. So in that case, one way to do it is the model service that you're deploying. Usually, and we didn't go into this detail there, the model service that we deployed with Spacey only had an init function and it had a predict function. Now, if you want to do online learning or do more complicated reinforcement style learning, having functions that can update your model in real time, maybe it's like do a gradient descent step or simulate a particular piece of data. Now, that's the kind of function that can go into your model definition itself, so that the code that's being deployed is still the same, except you can update your model in real time. We've seen more challenges come up with reinforcement learning at the training stage because you need to keep track of so many simulations and so many different worlds and what works in different worlds. In that case, I would actually say that managing those model experiments and versioning becomes super key. And we found in our experiments that having a place where you can look at all of those experiments turns out to be very beneficial.
Great. We had another one come through. I think you answered this. Maybe it came through before you covered it, but the question was, what is the advantage of using Jenkins here?
Yeah, for sure. So Jenkins is a way to make all of your build and release steps repeatable. As a data scientist, usually we only think about, oh, I built this model and maybe I built one Docker container. However, when that model gets deployed into a real system, you're gonna do that over and over again. So maybe it's every day you're updating your spam model, or every month you're getting new data about loan approvals and you're putting that into your model. In that case, you don't want to reinvent the wheel. You want a way to, anytime you say that there is a new model that is ready to be released, the Jenkins pipeline can package the model, deploy the model in a way where you don't need to babysit it.
Awesome. Another one, can we use Verta if we are using SageMaker to host our models?
Yeah, for sure. So let me differentiate ModelDB, Verta, etc. So ModelDB by itself is just a versioning system. You can use it with any downstream deployment system. So whether it's SageMaker or you have your homegrown system, that's totally fine. ModelDB is just your source of truth, just like Git is your source of truth. And then you can decide to package the models in a particular way, put them on SageMaker, build your own images, and so on. You can actually put SageMaker into a Jenkins pipeline too, so that you can continue to do your builds and releases in a reliable manner.
Great. And then there was one, does ModelDB do data versioning too?
Yeah, we get that a lot. So absolutely. And I would encourage you to check out our other webinar, which was ModelDB focused. When you get deep into what is model management and model versioning, you'll realize that there are 4 ingredients for a model. They're your code itself, your data, your config, and environment. And what ModelDB does is that it versions all 4 of those ingredients. So if you're on S3, then we're going to version your data sets on S3. If you're on HDFS, then that's going to look different. But what ModelDB will do is it will keep track of what exact data snapshot was used to build a particular model.
Great. And then last one I have here, can you say more about Prometheus?
Yeah, for sure. So Prometheus is an open source project. It's used for monitoring a lot. It's very popular with Kubernetes, but also with Docker. And the way that Prometheus works is any service that you want to monitor can expose a set of metrics. In this case, what we had was our metrics were what is the count of requests that have been made against this particular service. It can be very arbitrarily fine-grained, so you could have like CPU usage, you could have network usage, you could have memory usage, anything that's relevant. You can put those, or rather expose endpoints for those metrics, and then Prometheus is actually going to scrape those metrics. So then you can aggregate it, you can visualize it, and then you can see it in some dashboarding tool that you already use. So highly recommend using Prometheus, whether you're doing ML or otherwise. It's one of the most popular DevOps tools out there.
Awesome. So that's all the questions that I have. If there's any other questions that anyone has, feel free to reach out to us after the webinar. We're also going to be sending over some additional materials. We'll send you the webinar recording as well as the MLOps information. So stay tuned for that as well. And Once we end, we'll also be launching a quick survey, just 3 questions. So if you have a moment, please respond to those for some feedback, and we will give everyone a couple minutes back to their day.
Perfect. Thanks so much, everyone, for joining. All the code that Michael covered is in the Git repo. We'll make sure to resend that link in our wrap-up email for this webinar. But would love to continue the conversation. Please find us on Slack or on Twitter too, ver.ai, Data Serial. Would love to engage further. Thanks again for your time.
Thank you, everyone. Bye.
Bye.